Imagine a lightweight, portable box. This box neatly packages your application and everything it needs to run. This, in essence, is a container. Containers are like building blocks for modern software. They streamline development, testing, and deployment. Containers make it easy to move applications between different environments, like going from development to testing to production. Containers are crucial in the DevOps world. DevOps is about breaking down silos between development and operations teams, fostering collaboration and automation. Containers fit perfectly into this philosophy. They provide a consistent and reliable environment for applications, regardless of where they run. Think of containers as self-contained units of software. They ensure that applications behave consistently, whether on a developer's laptop or a massive server farm. This consistency is key to the speed and agility that DevOps promises. Without containers, achieving the seamless flow of software from development to production would be a far more daunting task. Every container begins life as a blueprint. This blueprint is a file called a Docker file. This file contains instructions for building the container. It specifies what software to install, what files to include, and how to configure the container environment. It's like a recipe that tells the computer how to bake your container. The Docker file is a human-readable text file, making it easy for developers to understand and modify. It follows a specific syntax that defines each step of the container build process. The simplicity and clarity of the Docker file make it a powerful tool for defining and managing containerized applications. Once the Docker file is complete, we can build an image from it. An image is a static snapshot of the container. It includes all the files and configurations specified in the Docker file. Think of the image as a template. From this template, we can create multiple running instances of the container. With the container image ready, the next step is deployment. This is where the container comes alive. We take the static image and spin it up into a running instance of the container. This running instance is what we call a container. Deployment can happen in various environments. It could be a developer's local machine, a testing server, or a production environment in the cloud. The beauty of containers is their portability. The same container image can be deployed across these different environments without modification. The deployment process often involves tools like Docker Compose or Kubernetes. These tools orchestrate the deployment, scaling, and management of containers. They simplify the complexities of running containerized applications, especially in large-scale deployments. Section 4, Phase 3, Runtime, the container in action. Once deployed, the container enters its runtime phase. Here, the application inside the container starts executing. The container provides the application with a secure and isolated environment to run in. This isolation ensures that the application doesn't interfere with other applications or the host system. During runtime, the container interacts with the outside world through exposed ports and networks. It receives requests, processes data, and sends responses just like any other application. Monitoring the container's health and performance during runtime is crucial to ensure the application is functioning correctly. Containers are designed to be ephemeral. This means they can be created, started, stopped, and deleted quickly and efficiently. This ephemerality is a key advantage in DevOps. It allows for rapid deployments, rollbacks, and scaling of applications. Section 5, Phase 4, Termination, the end of the line. Every container eventually reaches its end of life. This could be triggered by various reasons. It could be a deliberate decision to stop the application, the completion of a specific task, or an unexpected failure. Regardless of the reason, the termination phase marks the end of the container's life cycle. Termination involves stopping the running container and removing its associated resources. This ensures that the system resources consumed by the container are freed up. Proper termination is essential to maintain the efficiency and stability of the overall system. In a well-managed DevOps environment, container termination is often automated. This automation ensures that resources are used efficiently. It also prevents the accumulation of unused or orphaned containers, which can lead to clutter and potential issues. Section 6. Conclusion. Mastering the container lifecycle for DevOps success. Understanding the container lifecycle is fundamental to effective DevOps practices. It provides insights into how applications are packaged, deployed, managed, and scaled in a containerized environment. This knowledge is crucial for developers, operations teams, and anyone involved in the software development and delivery process. By mastering the container lifecycle, organizations can achieve faster deployment cycles, improved resource utilization, and enhanced application reliability. Containers, with their portability and efficiency, are transforming the way software is developed and delivered, paving the way for a more agile and responsive approach to software development. Embracing containers and understanding their lifecycle is not just a technological shift. It represents a cultural shift towards collaboration, automation, and continuous improvement in the world of software development.